This is standard 8EEC7. We're going to look at it backwards. We're going to look at the last half of the standard first. For one variable linear equations, you should simplify the equations into the form x equal A equals A, or A equals B to determine whether they have one solution, no solutions, or infinitely many solutions. Now, first, let's start with this one that has one solution, which is of the form x is equal to A. When we get finished, when we solve for x, or whatever variable there is, it should give us a number. If it does, then we've got one solution, one thing we can put in for x to make this equation true. Now, let's start out by solving for x, seeing if we have one value for x. First off, this expression is as simple as it gets, so I don't need to do anything to it before I cross the equal sign. Let's look at what we need to do to cross this equal sign, to get all the x, to get the x over here and all the numbers over here. First off, the 2x has 3 subtracted from it. The opposite of subtracting 3 from this side would be to add 3. See, the 3 goes away because negative 3 plus 3 is 0. But what I do to one side, I have to do to the other. Okay. This 3 is gone. This means 2x is equal to negative 11 plus 3. There's two ways to do this without a calculator. First off, you can look at negative 11 plus 3, and you can realize that these two have different signs, so I find the difference in them, which would be 8, and I use the sign of the one that has the largest absolute value. That would be negative 8. Or you can put this on a number line. You're starting at negative 11, and you're moving up 3. Okay, so let's see where that would put me if I move up 3. From negative 11, and I go up 1, 2, 3. That puts me at negative 8. Either way will get you there. So negative 11 plus 3 is negative 8. I now have 2x is equal to negative 8. I still need to solve for x. I need x by itself. 2 is multiplied by x. The opposite of multiplying 2 by x is to divide 2x by 2. What I do to one side, I have to do to the other. 2x divided by 2x is 1x, so that's just x. And I've got negative 8 divided by 2. A negative divided by positive gives me a negative. X is equal to negative 4. How could I check to see if that's right? I could plug it back in. 2x minus 3, here we're checking. 2x minus 3 equals negative 11. 2 times negative 4 minus 3 equals negative 11. 2 times negative 4 is negative 8. Minus 3 is negative 11. Negative 11 equals negative 11. This is true. Now notice, at the end of this, we got x is equal to negative 4. We said if we get to the end and we say x is equal to a number, then we have got one solution. That one solution is negative 4. What if we have no solutions? Let's look at this one. When we have no solutions, we get to the bottom and we have one number is equal to another number. But we know if the numbers are different, they can't be equal. So let's see what we do here. Again, guys, let's look to see what we've got. Do we have anything in this expression that we can simplify before we get started? Yes, we've got parentheses there. And we know the term PEMDAS, which tells us that if we've got parentheses, we do that first. We're going to distribute our 1/2 to the 4x. Half of 4x would give me 2x. Half of 2 would give me 1. That's as simple as that gets. So now let's work on the other side. Again, I have parentheses and I need to do those first. 2 times x is 2x. 2 times 4 is 8, so that's plus 8. And then bring down our minus 2. Okay, I still have something I can do here. I can collect like terms. The x and the -2, neither one have a variable with them. So I can say positive 8 minus 2. 8 minus 2 is 6. That gives me 2x plus 6. Now I've got 2x plus 1 is equal to 2x plus 6. Well, it's going to become obvious to a lot of you right here that there's no way I can have a 2x plus 1 equal to a 2x plus 6. But if that's not obvious to you, let's start here and let's try to get all the variables on one side. I'm going to subtract 2x from both sides. 2x minus 2x is 0, so there's nothing here. That's gone. 1 is equal to, and I got 2x minus 2x is 0. There's nothing there. 1 is equal to 6. 1 is equal to 6. Here I've got two numbers that I know are not equal to each other, are they? If they're not equal to each other, that means there's nothing that I can put in for x to get a solution here. There are nothing here I can put in to have these two sides equal. There's nothing that would make 2x plus 1 equal to 2x plus 6. I can't have a value and add 1 to it, have that same value and add 6 to it, and have them be equal. So there are no solutions. Nothing will make this equation true. And then finally, let's talk about infinitely many solutions. That's a situation where you get to the bottom and you have two numbers that are equal. Now, let's use our same thing we did a minute ago to solve our problems. We know that we need to simplify each expression first. Let's simplify this one. PEMDAS tells us we need to take care of this parentheses here, so we're going to do the distributive property. 2 times 3x is 6x. 2 times 7 is 14. Now we've got 7x, and we've got, since there's nothing in front of it, we know there's an assumed 1. Negative 1 times x is negative 1x. Negative 1 times 1 is negative 1. Okay, let's bring down what we have here. Collect like terms. 7x minus 1x is 6x. Negative 1 plus 15 is 14. I've got 6x plus 14 is equal to 6x plus 14. Those are exactly the same on both sides. A is equal to A. I could put anything in here and get the same answer, but let's prove it to ourselves. Let's get rid of the 6x. Let's subtract 6x from both sides. And I've got 14 is equal to 14. Look, same thing as A is equal to A. That means that I have an infinite number of solutions. I can put in anything for x and get these two sides to be equal to each other to get a true statement. Now let's do the first half of this standard. For one variable linear equations, give examples that have one solution, no solutions, or infinitely many solutions. First, we need an equation that would wind up solving as x is equal to a to only have one solution. What if I use something like this? 2x is equal to 6. If I've got that, let's check ourselves and see if that would work. Let's divide both sides by 2. X is equal to 3. Okay, that one works. How about one that has no solutions? Well, what if I've got 6x plus 1 is equal to 6x plus 2? We know this cannot work because if I've got a value 6x, you can't add 1 to it and then add 2 to it and get the same thing on both sides. But let's work it out and see if it fits this example. Let's subtract 6x from both sides. And I've got 1 is equal to 2. That's correct. There's no solutions. Now let's look at coming up with one that has infinitely many solutions. They need to have the same thing on both sides. How about 2x plus 3 is equal to 2x plus 3? These look exactly the same, don't they? Let's subtract the 2x from both sides and see. I've got 3 is equal to 3. And that's exactly what I have. Those two are equal.